Hello everyone, I am Dr. Sabrish, Assistant Professor, Mechanical Engineering, SRM Madurai College for Engineering and Technology. Today we are going to see some of the basic concepts in the strength of materials. So, the strength of a material is its ability to withstand an applied load without failure. Basically, a material has two types of properties. They are elasticity and plasticity. A material, when it returns to its original shape and size after removing the applied load, is said to be under elastic condition. Sometimes, when the material undergoes permanent deformation even after removing the applied load, then it is said to be under plastic condition. Deformations are caused by the residual stress developed within a body. So, a stress is a measure of what the material feels from the externally applied forces. It is actually a ratio between the externally applied force to the cross-sectional area of the force wherein the force is applied. So stress is equal to the applied force divided by the cross-sectional area. Usually the units are Newton per meter square or Newton per millimeter square. So from this image we can see that uh, the stress, one of the basic type of stress is direct stress, where this is the tension stress. We can see the tension stress. The tension stress is applied along the axis of the body, and here we can see the compressive stress that is acting along the axis of the body. So when we are applying loads to the body, then it will undergo some deformation, and this deformation will change the dimensions of the body. So when we consider this example, this is a bar and it is subject to a tensile load. Here we can see force F is acting along the axis, and this causes a change in length. Here we can see the length is elongated, and this elongated length is termed as dl, and that is the original length is L. So the change in length is the deformation, and this extra increased length is the strain developed within the body. So the expression for strain is change in length divided by the original length. Similarly, we know that the strain is the ratio of the length. Therefore, it does not have any unit. It is dimensionless. So for the compression stress, it will be the strain will be in negative, since there will be the reduction of the length. So similarly, as there are different types of stress, we can also see there are different types of loads, and these loads can be classified as a tension load and a compressive load. So tension load is something which causes the tensile stress. Here we can see we are applying tensile load along the axis of the body, and this is a compressive force acting upon along the axis of the body. So it is termed as a compressive load. And there is also another type of load called as a shear load. These are like opposing forces which do not act along the axis. So you can see the forces are parallel but they are opposite to each other. Here these forces tends to pull apart this body, and that thus it is a tensile shear force, and this pushes towards the body, and this is a tensile, this is a compressive shear force. There are also other types of loads such as torsional loads and thermal loads. Torsional loads means it is the angular distortion on a component such as shaft when we apply some twisting moment. So any sort of twisting force applied on an object that causes a torsional load. Similarly, thermal loads they cause distortion by heating or cooling of the respective material. So a normal load is created when the material is constrained. So when we are constraining any material, when it is under a heating or cooling, and when we constrain its motion, then that material is subjected to be under thermal. So this image shows the hydraulic machine used for tension and compressive test. Here we can see this part is where the testing material is secured, and when these jaws move apart from each other, that causes the tensile force, and that causes the tensile stress within the body. And when these move towards each other, that causes a compressive stress within the body. So by this means we can test the tensile and compressive limits of material. Next is the shear stress. So as we saw earlier, there are tensile and compressive stresses. and stresses that is developed due to application of shear force that is called as a shear stress. The shear stress are produced by equal and opposing parallel forces and that are not in line. So these forces tend to make one part of the material slide over the other part, as we can see from this image. So it causes the material to slide over each other along this along that a specific axis. So the shear stress is actually tangential to the area over which it acts. So that means when we are applying force over this side, that means this shear force is tangential towards the surface. So this image shows the much clearer picture of the shear stress and shear strain. Here we can see we are applying shear force towards this side and the shear force towards that side. So this causes a shearing moment upon this rectangle body. So this tends to move the body towards the opposing side. So we can see this is the displacement caused due to the shear force, and the area which overlaps between the previous position and the final position, that is the area resisting the shear, and the angle which is made between the initial and the final position, that angle is called as the shear strain angle. And this motion, this the new area which is covered now, that area is called as the shear strain. That is a strain, that is a deformation, so that is called as a shear strain. Similarly, there is another important factor that is needs to be considered while designing materials and structures. That is the ultimate strength. The ultimate strength of a material is a measure of stress that it can take when in use. So, ultimate strength basically means that the strength of a material and after which it breaks. That means we can apply load on a material until the limit of its failure. That limit is called as the ultimate strength. So this image shows the relationship between the stress and the strain. So when the material is under elastic limit, wherein when we remove the load, it comes back to its original shape and size. So under that situation, the stress is directly proportional to strain. That means whatever stress we are applying, a corresponding strain will occur. And when that stress is removed, the corresponding strain will also be. That is the condition under elastic deformation. So when the material is well over its elastic limit, then it is supposed to undergo plastic deformation. So during plastic deformation, the relationship between the stress and strain varies. Here we can see from this graph, the stress, it actually, the curve between the stress and strain, it curves, and the slope is varying. We have a bigger slope. This means the slope from here and the slope observed over here are totally different. That means this area between the stress and strain, the slope, that is the permanent deformation. That is the strain caused in the body during the plastic deformation stage. So based on this, we can establish some basic laws. So if the strain is elastic under elastic limit, then there is a law governing the strength of a material known as the Hooke's law. Hooke's law introduces a specific constant in order to relate the stress and strain. So that constant is the Young's modulus. So Young's modulus basically is the relationship between the stress and strain. So Young's modulus is a ratio of the applied stress and the resulting strain. The Young's modulus is also called as a modulus of elasticity, or it is a measure of stiffness of a body. So all solid materials deform when they are stressed, and as the stress is increasing, the deformation also increases. So when the material returns to its original shape and size when removal of the load, and then it is supposed to be elastic. That is the elastic limit which we discussed earlier. So based on this, there is a law that is called as the Hooke's law. So the Hooke's law states that by providing the limit of proportionality of a material is not exceeded, the stress is directly proportional to the strain produced. So if the graph of a stress and strain is plotted as the load is gradually applied, the first portion of the graph will be a straight line. So that is what we saw earlier in this graph. Therefore, based on these, we can derive some expressions. So the modulus of elasticity, that is the Young's modulus, E, is termed as direct stress or direct stress. For shear stress, the modulus of rigidity, it can be, there is also different types of modulus for shear stress, that is called as the modulus of rigidity. That is expressed by the term G, and its relation is shear stress by shear strain. Similarly, for volumetric strain, wherein the strain is applied throughout the strain which we obtain is throughout the volume of the body, that is proportional to the hydrostatic stress within the elastic ring. So that relation, that modulus is termed as the bulk modulus. Introduction, we have seen discuss some of the basic concepts. They are the types of different types of stresses, the different types of loads, the relation between the stress and strain, and we have also seen what is strain, and we have also discussed about the different types of modulus. So these are the some of the basics of the strength of materials. Thank you.